Hi guys, Mr. Fassin here. Welcome to Science Tech for Fun. Today I will show you how to use a dynamic rock for the acceleration core practical. Some schools, they might not have a dynamic rock like ours, but here in Saracens we use a data harvest for this practical. So I will show how to assemble and how to measure. So this practical, we will split in two videos. First part will be how to assemble everything. Second part, how to set the data harvest. So first things first, what equipment is involved? So this is my dynamic rock. So a dynamic rock is basically a meter ruler where I can use as a rail as well. So in this meter ruler, in this rock, I will have two parallel rails running where my car will run stable. I also have a meter ruler from my side where I will have the stands. So this is where I'm gonna place my sensors. In this case, light gates. So light gates is sensors that trigger, start reading or stop reading every time the laser here is cut. Okay, so when it's cut, start reading. When it's cut it again, stop reading. I will also need a data harvest, cables to connect my sensor into the data harvest. I will need my cart with a piece of string attached. This is where the force will be applied. The force, we will use masses. For this practical, we're not going up or above the 1 Newton. So each coin or ring of mass is 0.2 newtons. So in total, we have 1 Newton here. 4 masses plus the hang, 1 Newton in total. We also need blue tag because a second part of this practical will involve the cart changing the mass and the force being constant. And for security, we use a tray with foam inside. In the case of the card jumps out of the rock, this flies and land inside the foam and the equipment is not broken. Okay, so let's start with the assemble. So the first thing I need to do is open the rock. So you're gonna receive the rock closed. There is a knob on the screw here, so you just need to release a little bit, then you can open up. Make it flat. So there is 2 legs or feet here. So make it flat. When it's flat, you just tie the screw again to make the system stable. Then you open your pulley on the side, tied it up, and then we're going for sensors, okay, and cables. Position of the sensors. At this point, doesn't matter if it's this way, doesn't matter. So one sensor goes one side, the other sensor goes in the other arm, okay? So there is a screw here. We just screw down and tied the screw to keep this hold, okay? Then the cable. The cable is like an old cable for laptops or for PCs. So there is this flat part here that's aligned with this flat part. So just connect and put inside. When it's done, it's stable and tight, okay? This goes here, and then you screw tied in your sensor in the arm. The same apply for this one. So my cable goes here. and then I tied my screw. Now comes the tricky part. It's not difficult, but you need to pay attention. So in my data harvest, I have 1, 2, 3, 4 portals. This means I can have 4 sensors reading at the same time. For this practical, I have 2 sensors. I'm gonna call it A and B. A will be the first, B will be the second, okay? Why? Because my car will be running to left to right, and gonna cross first this light gate, and then second this light gate. So what my data harvest will measure? The time between A and B. So I can have this distance that I know, because I placed the distance between the 2 light gates, 30, 50, 1 meter apart, so I know the distance. So this is going to be measuring the time between A and B. So I will be able to calculate the speed and the acceleration, okay? So this is the closest one for my initial position. So this must be A. So when I'm assembling in the data harvest, the cable have to come here on A. Then B will come here in B. If you miscross it and you place A on B and B on A, you won't have the measurings. So this will be completely wrong. You won't be able to have measures, okay? So this is the important part. Always remind, A on A, B on B. A is the first where the car is gonna cross. B is the last where the car gonna cross, okay? So this is gonna be here, set. Then I will place my card here and set the string. The practical will ask you to start with a small force. So this hang will go in the loop at the edge of the string, and then I will place it here. The card will have its mass. The mass of this card specifically is 500 grams or 0.5 kilograms, right? So then when I have my system running, I just release and we'll measure the time between A and B. This must be placed down here. So if in the case the car drops, the phone, as I said, will hold it and the car won't break. Some practicals will ask for the car to be already running. Some practicals will ask for the car to start from a zero velocity to start running, okay? So if you start with 0, the car should be a little back from my light gate. For when this starts running, the acceleration comes and carry on. And when it's crossed again, we'll stop reading. The second part of, obviously, for this practical, then you measured with your 0.2 newtons. Then you're going to increase for 0.4, 6, 8, 1 newton in total. So what you're changing is the force applied on this system. The second part of this practical is the force will be constant, so you can use, for example, 0.6 newtons. So this will be constant. You're never going to change this. But what we're going to change is the mass of the car. So that's why we need the blue tag. So the blue tag will go here and we'll place here. Okay? So the mass of the car will change. So then you're going to evaluate how long it takes between A and B with the card with an extra 100 grams, an extra 0.8 grams, 60 grams, 40 grams, 20 grams, and see if the acceleration will change, okay? So now, keep with us, bear with us for the video number 2.